This is Josh White with JW Math Tutoring. Today's video is going to focus on the Desmos advanced skills that you need to ace the digital SAT math test. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Welcome back to my ultimate Desmos guide to digital SAT math. This video is going to go over advanced skills, which are basically Desmos operations that you need to know if you're aiming to score 700 and above on the digital SAT math section. Because these specific skills are generally what you're going to use on the hard level problems. Most likely the ones you would see in like the last 4 or 5 questions, typically of Module 1, and also appearing in Module 2. Typically towards the end, but not necessarily, at the end. So just a couple things before I get started. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Obviously, I have other videos, that are part of this guide. There's the intermediate skills video. There's also the core skills video, and just a basic introduction to Desmos as well. But if you're here watching this video, I'm assuming that you do have some familiarity with Desmos and most likely already know how to do those things in the core skills and intermediate skills videos, even if you haven't watched them. Lastly, the PDF file for the Desmos operations worksheet, basically the thing that you see on the left side of the screen right now. There'll be a link to that in the description of the video, and also a link to the example problems that I'm going through as well. So both of those will be in the description of the video. All right, so for this first one, which is solving a formula for a specific letter, there are 2 different types of problems that you can encounter, and you have to solve each of them a little bit differently. So I'm going to go through the first type, which is when you have a formula that's given with one letter equal to everything on the other side, and go through an example problem of that. Then I'll come back to this operations sheet, talk about the second type where you have like multiple letters on both sides. All right, so the first type of problem, this is method 1 on the sheet here, is when you have a formula where you have one letter on one side and all the other letters and terms and numbers on the other side. Okay, and basically what you're going to do is you're going to type the formula into Desmos. You're going to add sliders for every letter in the formula that you see except the one that is on the left side. Then you're going to go through and you're going to type the answer choices, okay? Really, you're only going to type the right side of the answer choices. After that, what you're going to be looking for, or what you're going to be comparing, is the value for each answer choice to the number that you chose for the letter that you're solving for in the slider for that letter. Okay, so this sounds a little confusing, but I'll show you exactly what I mean as I go through an example problem here, and you're going to see it's actually not, it's not that bad. So here is a formula, okay? P equals 8 plus 15 over n. Now, you're given some conditions here. We don't really need to worry about that so much. And essentially what you're doing here is you're solving this formula for n in terms of p. All right, so the way that this works is following the steps. Step 1, we type the formula in, okay? Step 2, we're going to add some sliders for basically every letter except the one that we see on the left side. So nothing for P, we're only going to add sliders for N. All right, so I'm just going to say, let's see here, N is not equal to 0, so whatever. I'll just say that N is equal to 2. All right, so notice that tells me that P is equal to 15.5. Now I'm going to go and I'm going to type all the answer choices in. So there's A, there's B, there is C, okay, and there is D. Now, again, just to go back to the sheet for a second, what we're looking to match is the answer choice which is equal to the same value or same number that we chose for the letter in the slider, the letter that we're solving for, which in this case is n. So what that means is I chose n to equal 2. So I'm looking for the answer choice that is equal to 2 because these are all equal to n, essentially. Notice in the answer choices, they're all n equals. So the correct answer for this is going to be D right here because that's the one equal to 2. And also just to confirm, if I picked a different value for n, say like this. Okay, now I'm looking for 13.172. Scroll down. N is 2.9, and what I'm looking for again is 2.9, which is going to be the last one down here. Again, this number actually doesn't matter. I shouldn't have mentioned that. All we're caring about is whatever I move the n value to, that is what I'm looking for down here. So 3.7, again, D gives me 3.7, none of the others do. So this is the method you use when the equation starts with the equation or the formula has one letter alone on the left and every other letter term number on the right. Okay, so now to go back to the operations sheet. The second method is what you use when you have multiple letters on both sides. Okay, so what you're going to do here is you're going to type in the entire formula, but the letter that you're solving for, you are going to replace with Y. So whatever letter you're solving for in the answer choices, that letter becomes Y. Okay? This is going to end up graphing a horizontal line on the graph. Then you're going to add sliders for all the other letters besides the one you're solving for. Then you're going to type in your answer choices, and you're going to see which one overlaps or matches the horizontal line that we graphed in step 1. Okay, and you could technically use X instead of Y. It would just give you then vertical lines instead of horizontal lines. So if you want to do it that way, like that's fine. So just keep that in mind. You could use either X or Y. All right, so now going back to the example problems, here is an example of a formula that we are going to solve for Q. So what I'm going to do first is just type in the formula. All right, so now I'm going to add some sliders. I'm going to add a slider for P and for R, but remember the Q I really want to equal, I'm going to change that to Y. Now I'm going to let P equal, whatever, 2, and I'm going to let R equal 3.5. Okay, now if you notice here, there actually is a slight problem, and this is something I mentioned in my introductory video. Technically, you can't use R because R is defined to be like the radius of a circle. So I'm going to instead change this R just to S, only for the purposes of this problem. All right, so now that I've done that, notice here I have a horizontal line at 1 point something. The actual value doesn't between 1.2 and 1.4 looks like between 1.2 and 1.3 actually. The actual value doesn't matter because all we're looking for is an overlapping line on top of it. So now what I'm going to do is I'm going to type out the other answer choices, and you don't need, remember Q is being replaced with Y, so you don't have to type the left side, but if you want to, it's just going to be Y equals, okay? So again, I'm going to do this. Again, every R is being replaced with S. And now this is going to be P plus S. By the way, it looks like answer choice A is overlapping it identically, so that is probably the correct answer, but we'll just, double check and confirm here. This is going to be S minus P. And now for the last one, S plus P divided by PS. Okay. So notice here, just to go through these one by one and take them each off. All right. So here's the red, here's the purple. Notice this overlaps it perfectly. That seems to indicate this is the correct answer. But notice, does this overlap it? No, not the correct answer. Does C overlap it? No, not the correct answer. Does D overlap it? No, not the correct answer. Correct answer for this problem is A. So this is how you can solve a formula for a specific letter when you have, basically not, this is what you do when you do not have just one letter equal to everything else on the other side. Okay, again, this is a slightly different approach than what I did for the previous problem, which is where we had p equals and everything else on the other side. Here, the q's in a denominator, not the numerator, and there's a number of it. So this is the approach you have to use for this specific type of problem. All right, so going back to the sheet, let's talk about the next operation on here. This is just using sliders in a table of values for regression. Most likely you would use this for quadratic regression, but you can use it for exponential regression as well. There's been several questions we've come across um, that I've seen from reported from official exams that have exponential functions, and you can use sliders in those. So essentially, all you're going to do is, and this example here in the document in the far right column is geared specifically towards a quadratic example, but in your table of values, your x1, y1, you're just going to, put some letter, could be D, could be whatever you want in there, and then you're going to add a slider, and then what you're going to do is you're going to move that slider, and you're typically going to look at what that does to the regression that you run. What does that do to the A or B or C values in your regression? So let's look at an example problem so I give you a better idea of what I'm talking about. All right, so in this example, you have a parabola. It has a vertex of negative 7, 12. Okay, it intersects the x-axis at 2 points. And if the equation is in this is basically standard form, it wants to know, which of these could be equal to the value of A plus B plus C, your three coefficients. So the way you can solve this is by doing a table and quadratic regression. But the problem is you're only given one exact point. So, if you try to do this, just using that one point, it doesn't really get you anywhere, right? Notice this doesn't meet, this does not meet the criteria of the problem that it says, it intersects the x-axis at 2 points. Also, this is the vertex as well. So what we can do now is we can go to the table and I can say, okay, well, I know that the two x-intercepts are going to be symmetric with respect essentially to the vertex, meaning one of them is going to be the same distance horizontally to the right, and one is the same distance horizontally to the left. And since they're x-intercepts, I also know that their y values will be 0. So now what I'm going to do is I'm just going to set a slider for D, okay, and now my quadratic regression here has given me A, B, and C values. All right, and so notice here's my vertex at negative 7, 12. Here are my two intercepts. Good. So what you can do now is you can see, what is the value of A plus B plus C? So notice this is some gigantic negative number. However, as I move the slider, notice it eventually gets to 0 right here, and then I'll just zoom out. Even when I get to 10, notice it starts to get positive. So if I jump this up, let's say to 100, right? And we can just set the step value to 1, that's fine. Notice it jumped through 9 right here when the D value is 16. Notice it's equal to 9. So it looks like the correct answer here is going to be A, because I found a specific example where A plus B plus C is equal to, 9. Notice it keeps getting bigger and bigger as the graph gets flatter and flatter and flatter. And basically, what's going to happen is, and you could like jump this up to 1,000 or whatever. The It's going to approach 12. It's going to get like really, really, really close to 12, like 11.99999, but it's never going to get to 12. So it's never going to be able to get to 15, 21, or 24. So this is how you could use sliders in a, in this specific case, quadratic regression to solve a problem, because you're only given one point, but you're also told that there are two x-intercepts. And again, we don't know the specific values of them, but we do know that they will be symmetric, on either side of -7, basically. And then we just use the slider to find, the different values, and that basically helps to tell us that 9 is the correct answer because we can pass through 9, but not any of the others. All right, so going back to the worksheet, just the last thing now at the bottom of the first page of the advanced operations is running regressions on specific point values. So you can also do regressions in the two ways that you see listed here on the screen. So in the top example, basically what this is saying is the essentially the y values when you plug in 7 and when you plug in -3 are both equal to 0, i.e. those values are both x-intercepts. It doesn't have to be 0, it could be some other number as well. Um, the 0 part is not specific to this. The second example here is, I guess, it's written slightly differently. But this is what you would do if you don't know the specific y value. Here, you're just regressing the two y values to themselves, even without knowing what they are. In the top example, it's like you know what the y values are for both points, but in the bottom one, you don't. So this is another advanced technique that you can use to solve certain types of problems. Again, most likely, you're going to do this with quadratics. Um, from the examples that I've seen so far. So let's look at an example problem here. So you're given this quadratic function, okay, x squared plus 10x plus c. But what has this vertex, h and k constants, okay, whatever. You're told h is positive. You're also told that f of -2 equals f of 4. So what you're going to do here is you're going to type in this function, and then we're going to run a regression where I regress f of -2 to f of 4. So in other words, it's saying for this f of x function, when I plug in -2, I get the same y value as I get from when I plug in -4. Okay, so couple things. First, look at this one specific example it gave me. Is the h value greater than 0? The answer is yes. The x-coordinate of the vertex is 1. So that condition is met. So that's like this example it gave us so far is good. It meets the criteria. Now, which of the following must be true? Okay, is it true that a is less than 0? Well, in this case it is. It's -5, so it appears to be true. Um, and is it true? So whatever, we'll leave this one for now. Is it true that c is less than 0? So here the c value is 0. So we found at least one example where c is not less than 0. It's equal to 0, which is 0 is not less than 0. Therefore, this does not, is not necessarily true, or does not have to be true or must be true. So this is gone, this is gone. We're basically down to A or D. So now what you could do is we could try doing the other type of regression. And so notice here, so now what I'm doing is I'm picking specific values for f of -2 and f of 4. So if they're both equal to 0, okay, notice we still get a negative a value. We do not get a negative c value, though, but again, we already ruled out that c does not have to be negative. Let's say I make this 10. Notice what happens here. If you make the values larger, it just, the a value is not changing. Okay, do you see that? It's just the a value is still staying constant, -5. All right, what about if I make this negative? -5, -25, -100. Notice here it did make the c value negative, but notice the a value is still -5. The a value is fixed, it is constant, it is not changing. Therefore, we can reasonably conclude that the a value must be less than 0, based on like all these different examples that I've tried, and you can see that it's going to open down regardless of where I set the y values for these 2 points equal to each other at. All it's really doing is it's just shifting the graph up and down. It's not changing the direction of it. Continuing with the advanced skills in this ultimate Desmos guide to the digital SAT math test, at the top of the second page, we have a skill or an operation, which is basically finding the value of a constant or constants to match expressions using the process of regression. So basically, these are problems typically where you're going to be given usually some operation uh, between two rational expressions, adding or subtracting two rational expressions together, and then you're told it equals something, and the expression that you're told it's equal to is going to have, like whatever, maybe A or B or C or whatever in it, and then the question is asking for, whatever, what's the value of A plus B plus C, or what's the value of A times B, or, something like that. Basically, they're asking for the constants that you would get, which are the coefficients of some of the terms if you actually did the problem out. And also, it doesn't have to be rational functions. You could also use this for just any, thing, like, multiplying two polynomials together and figuring out what you know, the coefficients of some of the specific terms are. So there's actually two ways you can do this. The first way is what I think is the simpler and easier way, but I will show you the second method as well. And the first way, basically what you're going to do is you're going to type kind of like the two things that are supposed to be equal to each other, except all the x's are going to have x sub 1 replaced for them, and you're going to use a tilde instead of an equal sign. And then the second step, and this is really important because you have to do this in order for it to generally to work properly, you have to create a list for x sub 1, which means you type x sub 1 equals, and then you put brackets, and inside the brackets you put at least two values. Sometimes you need more values, sometimes you need only two values, but you have to do that. And the reason is because you don't want Desmos to treat x1 as a constant. You want Desmos to treat x1 as a variable, meaning you want Desmos to find the value of the constants, whether it's a and b and c or d or whatever, such that uh, the two expressions on either side of the tilde will be equal for multiple values of x1. Okay, or in other words, for all the values of x1 that you put in that list. So it's very important that you do that in order to get the correct answer. All right, so now let's look at an example problem to show you what I mean. So here is an example problem. Okay, at the start of it, you have two rational expressions that are being added together, and it tells you it's equivalent, to ax plus b over, basically the common denominator, and it wants to know what's the value of a plus b. So what we're going to do is we are going to go into Desmos, and I'm going to type essentially the left side, which is the two expressions that are being added together. You got to make sure you put x1 for each thing. And then once we're done with that, And we use the tilde, and now I'm going to type the right side. Okay, so let me just expand this so we can see the full thing. A couple things to point out. See, notice here, these are not the right answers that it's giving me. And the reason is because it's treating x1 as a constant just like a and b. But we don't want that. Again, we want x1 to be treated as a variable. We only want it to find values for a and b. So what I'm going to do is I'm going to define x1 as a list. And the way that I do that is I type in some numbers here. Notice, once I type at least two values, it now gives me answers for A and B. And these are the correct answers. So what is the value of A plus B? Right there, A plus B is 2. Now, sometimes for problems, what you do want to check is, if you put in more numbers to your list, does it change the values? Because oftentimes it will end up um, that you need more than two numbers in order to make it give you the correct answers. But see, notice here, nothing's changing, right? It's still saying 37, negative 35, blah, blah, blah. Okay. Now, a couple of things to know about these list values. Typically, I just start with like 1 and 2, unless like those are restricted numbers, meaning if I could not plug in 1 or 2 because they gave a 0 in a denominator or there was some other type of domain issue, then obviously I wouldn't use them. But I typically just start with 1 and 2 and, go from there. Also, generally, I usually try to do at least the number of items in the list, which is equal to the number of constants you're finding. So in this case, we're finding two constants, A and B. So I would, at a minimum, start with two items and see what it gives me, and then possibly try, like I said, 3 or 4 just to see if anything changes or if there's any difference between that. But this is, again, this is the first method to basically equate. Really what you're doing is you're equating kind of two expressions to each other and finding the constants that make them equal. All right, so now I'm going to talk about the second method to do this. So just to go back to the reference sheet. So essentially what I'm going to do here is we're going to graph the left side of the equation, meaning that's typically when I talk about the left side here, what I mean is we're graphing the side of the equation, or in this case regression statement, which doesn't have the constants, okay? The side that just has the x's in it. Then I'm going to pick several points on that graph. I'm going to type them into a table, and then I'm going to do a regression, y1 tilde, so on, using the other side of the equation. All right, so let me just get rid of this for right now. So that means I'm going to graph the following. And of course, when we graph, we're just using regular x now. We're not using, x, the x sub 1. Okay, so here I have graphed basically what was on the left side, right? So I'm going to pick some points here. It's generally best if you can pick integer values, to use for your points. So 0, 7, that one had nice integer values. Maybe I'll try this one, 9.9460. There's at least an integer value for the y. Let's see here. This one doesn't have integers. Maybe I'll try this one. Here we go, 1.9.853. We'll see. Maybe we'll see if we need more. Hopefully we won't. But so now what we're going to do is, again, do a regression. And of course, because the columns here are x2 and y2, that's why I'm going to use type x2 and y2. So now what I'm going to do is I'm going to basically type, the right side here, meaning a x2 plus b, and then over, let's make sure I get this right, 2x plus 5, 3x minus 1. All right, and let's see, I just forgot to put the subscripts here. Okay, so here is one of the problems with this approach. Notice it's not giving me exactly 37 and 35, and the reason is because these are not exact values. You know what I'm saying? They're most like they're rounded off. It's not just 0.946. There's extra decimals after that that I don't have. So that's really ideally why, if possible, you want to use. See if you can find. Okay, so like here it looks like the negative 1.397.53. Let me just see, it gets a little bit closer now, but it's still not exactly at 37 and 39, which is what we're looking for. So if I trace along here, basically what I'm looking for is something with not 3 decimals in the y coordinate value, because that would mean that it actually is truncated. There we go, negative 3.63, negative 6.3. Okay. And you can see now it's really, really, really close, but it's still not quite correct, because if I did A plus B, well, actually, sorry, let me get rid of this because that's where it's trying to read from there. See, I get 1.995. So if this was a multiple choice question, okay, most likely you would realize, well, the answer has to be 2. But if it was a free response, I mean, technically you would put down 1.995 because you got to fill up all 5 decimals, all 5 character spaces, but that's not correct. The correct answer we know is positive 2. So that's why I hesitate to use method 2. I typically like to use method 1 unless the only way I would recommend using method 2 is if you want to use it as a check for method 1, meaning you've already done the problem once and you have extra time and you want to just check it using another method. Or you can easily find some integer point values. You know what I'm saying? Where there's no decimals, both the x and y coordinates are integers, and that way the regression should work out correctly and give you the exact values, that you would expect, say, for A and B in this case. All right, so next we're going to talk a little bit more about regressions. Now, these are going to be very similar to the linear regression, that I looked at in the core skills video, but some of these are a little bit more complicated. Basically, you have exponential regression. There, you can also do rational function regression. You can do radical function regression, and you can also do regression with circles. That's a special case, so I'll talk about that, after I go through these other types. So most of these are fairly straightforward in that you're just going to type in whatever form you are told the problem is in. So if it's like exponential and they tell you it's a b to the x or whatever it is, b c to the x, whatever the given form is, you would just type it in that form. Same thing with the rational function. So here is just a base example where it's, a constant on top over, something x plus 1, but you could also have rational functions where there's, mx1 plus b on top, and then another linear function, with a different slope and everything on the bottom, so one line over another line. And same thing, of course, with radical functions. That's just a generic example here, but it could be slightly different depending on, again, what it gives you in the problem. So I'm going to look at an example problem now, and like I said, then I will come back to circles and talk about that in a little bit. So let's look at exponential regression. So here you have a word problem, and it gives you the basic kind of formula right here, okay, for these number of bacteria cells on a piece of bread, right? And so they tell you start with 800, so that means when time is 0, you have 800 cells. Then 4 hours later, you have 3,200 cells. All right. R and C are constants here. P is the number of bacteria cells, whatever, after the time of T hours. So you want to know what's the value of R. So we can just do this easily in Desmos using exponential regression. So we first just make a table, put in our 2 points, and now y1 is just essentially replacing p. Can put capital C, and then we can put r, and then we can put x1 replacing t. So now it just comes back. C is 800. So, and this is correct because if you're familiar with the general format of exponential functions, C is in the spot where the initial value or starting amount goes. So that matches, that's correct. And R in this case is 0.5 or 1/2. So the correct answer to this problem would just be, looks like letter A. No, not letter A. What am I saying? Letter B, right here, 1/2. All right, so that's a basic example involving regression of an exponential function. Okay, so let's go back to the worksheet now and talk a little bit about circles. So the typical way you would use circle regression is you would have on one side the basically kind of the, well, I guess it's not really the equation of the circle, but it's more really what I would call the expression of the circle, um, given it not in standard form. And then on the other side, you would have the equation of the circle in standard form, x plus h plus y minus k squared minus, whatever squared. And so what you have to do is essentially you have to take each circle equation and you have to get it equal to 0. And then those two things that are equal to 0, those are what you are going to regress to each other to find the center or radius of the circle. Okay, so here is an example of what I'm talking about, just to go look at, one of the problems. All right, here is an equation of a circle, and we want to know what is the length of this circle's radius. So I'm going to do this using circle regression. First step is you have to get everything on one side equal to 0. So you need to subtract the 279 minus 4 over to the left. Okay, so the whole thing's equal to 0. Then what you're going, and then, so, okay, in standard form, the equation looks like this, right? But you have to subtract the r squared over again, so everything is equal to 0. And then those are the two things that you regress to each other in Desmos. So now what I'm going to do is expand this out. And this obviously is going to take a little bit of work to type out because you got to do all the sub ones. And the other thing too is that you will have to do a list. Sorry, this should have a squared on it. You have to do a list for both x and y. So they both will need to have a list with multiple elements in them. Okay, so there's the given equation. Again, it's set equal to 0. That's a 1. That's a 2. 1 minus k squared minus r squared. Okay, so now what we have to do, so these answers that you see on the screen here, for all the parameters, they're completely wrong. So first, we're going to make a list. Okay, this one, I believe when I did it out previously, I had to put in a lot of values. I don't remember why exactly, but I just had to put in like 8 or 9 numbers. Okay, now we're going to do it for y1. Let's see here, it's getting closer. 10. There we go. So once I got out here to at least 10 values in my x1 list and 11 values, probably, let me see if I can, yeah, we only 10 values in both my x1 and y1 list. This is the correct answer of the circle here. In other words, the radius of this circle is 9, and the center is negative 1.5 comma 3. Okay, and just to prove that, I'll just go ahead and type in the original equation here. Okay, so here is my circle. Notice it goes from 12 to -6. 12 minus -6 is a distance of 18 units. That's the diameter. Divide that in half. That would be a radius, and your radius is 9. And again, to find the center, this was something I covered in my intermediate skills section. We can just find the midpoint of, was it -1.512 and -1.5, -6. Just make sure. Yep, those are both correct. So let's label it right there, -1.53. H is -1.5. 3 is the value of K. R is equal to 9. Those all check out. This is how you can do regression with circles. If you are trying to easily find the center or radius of the circle and you're given the equation in not in standard form, just whatever generic random form that you're given the equation in. One other thing to mention too for this, if you're trying to do regression with circles, you have to have the same coefficients in front of the x1 squared and y1 squared terms on both sides. So that means if this had a 2 in front of it and this had a 2 in front of it, like that completely messes everything up and it's not going to work. Because in the standard form equation, you don't have 2's out in front here. Okay, you have a coefficient of 1 on the x1 squared and y1 squared. So if the problem was given like this, then what you technically have to do is you have to go through and you have to divide everything by 2. And that means every single term, because you need this. If you divide it by 2, it's just going to turn into an 8, because you need the x1 and y1 to have the same coefficients as the on both sides, basically. Okay, so that's one other thing just to be aware of as well. Now, one thing I just want to mention about this problem we just completed is if you look at this problem as given, you can get the radius of the circle, obviously, just by typing in the equation as given and then using the distance formula, which is what I did at the end of the problem to verify it. So the point is, uh, you would not need to do circle regression on a problem, say a relatively straightforward problem like this. If you just came across a problem like this on the SAT where they gave you essentially the full equation, even though it's not in standard form, okay, you do not need to do circle regression to solve that. However, where you would need to use or might want to use circle regression is if the equation they gave you had some type of constant in it. So, in other words, it had a p in front of the x term, or a p in front of the y term, or I don't know, a p in front of the x squared and the y squared, or something like that. Okay, so there was one example that came up on one of the recent tests. I'm trying to think. It's either November, I can't remember. It's either November or December, where there was a problem which was similar to this, where it had, where you could solve the entire problem by doing circle regression. So just be aware the point of this problem was to demonstrate how doing regression with circles works. When you're actually trying to type it into Desmos and work out the problem, even though obviously, like I said, this specific problem could be done without using circle regression, just by typing in the equation, using the distance formula between the maximum and minimum points, dividing that by 2, and that's your radius. Okay, so just want to make sure that everyone is aware of that and is clear on that. All right, so now let's go back to the guide and look at the next advanced skill or operation. So this is what I call using sliders to solve a single equation with a constant. So basically what this is are problems where you have an equation, and obviously it has a variable in it, typically an x, but then it also has some type of constant in it. Like a lot of times we see c, but it could be any letter really. It could be z, whatever. And the problem typically will ask for the solution or one of the solutions to this equation, And the answers are all going to be basically, formulas. They're not going to be numerical values, obviously. They're going to be formulas with the C or the Z or the whatever in it. Okay, so this is the type of problem that I'm talking about when I talk about solving a single equation with a constant. And all you're going to do is basically graph, y equals the left side of the equation, graph y equals the right side of the equation. You're going to add a slider for the constant, or if there's multiple constants, then you're going to find the solutions, i.e. the intersection points on your graph. And lastly, you're going to type in the answer choices, the formulas, and you're going to see which answer choice gives the same numerical value as the solution or solutions that you found from the graph itself. The one thing to be aware of is that sometimes, depending on the shape of the graph, it can be difficult to find the intersection points. So feel free to move the slider around as needed. Make the constant value larger or smaller to make the intersection points easier to see. All right. So scrolling down here, we have two different types of problems that I'm going to go over. Okay, so the first one here, you're given this equation. Again, notice it has a constant in it right here, a. And so a is a constant, a is greater than 20, and it says, which of the following is the solution to this equation? So going through the basic approach, I'm going to graph y equals the left side, which is x minus 19. I'm going to graph y equals the right side, which is x plus a times x minus 19. I'm going to add a slider for a. Let me just zoom out here. And now notice a needs to be greater than 20. So I'm just going to right away just put it to 21. Doesn't say that it needs to be an integer. So, I mean, you could go 20.1 or whatever, but I'll just make it 21 just to start. All right. So now notice we have two solutions, two intersection points here, right? So now we're just going to type in the answer choices, the four multiple choice answers, and see which of them matches either positive 19 or negative 20. So we've got negative a, we've got negative a plus 1, we've got a plus 1, and we've got 20. Okay, so again, the two things we're looking for are either positive 19. Do we see positive 19 in any of our answer choices? No, we do not. So okay, that's not going to be the solution we want. Now, do we see negative 20 in any of our answer choices? Okay, yes, we do, right here. Answer choice B, negative 20. So that is going to be the correct answer to this problem. Now, we could also just move the slider to another value just to confirm that it will still be answer choice B. So let's say I jumped it up here to 30, right? Okay. Now notice these answer choices automatically adjusted. So my two solutions, okay, one of them is still 19. Okay, I don't see 19 anywhere. But down here, I now have negative 29. So do I see negative 29? Yes, it's the second one listed. It's answer choice B again. So this is just confirmation that regardless of what value you pick for A here, as long as it's greater than 20, you should get answer choice B as the correct answer. All right, so now let's take a look at another problem. This one's a little bit more complicated, but it's not too bad. So here we have an equation, and notice it has x's in it, which is our variable, but it also has k, which is a constant. All right, and we want to know which of these following expressions is a solution to this equation. So again, I'm going to go through the same approach, which is to graph y equals the left side. I'll add the slider for k in a second, and then graph y equals the right side. Okay, now I'll add my slider for k. Notice it does not, all it says is k is a positive constant, so whatever, we can just start with 2. or maybe, I don't know, maybe 1. All right, so now we can type in the answer choices. And then we're going to have some square roots. And we should have one more to type in. Yeah, notice D comes back undefined, so we can automatically basically like ignore that one or cross that one out. That one's never going to give you uh, at least for choosing say k equals 1, which meets the conditions of a positive constant, you're not going to have a positive number under the radical. So therefore we automatically know this is wrong. So we're down to A, B, and C. Okay, so now the key is where are the intersection points here? We're trying to find intersection points either at x equals 1, x equals negative 1.3, or at positive 0.816. So see, the thing is, these graphs, these rational functions are a little tricky to see, but if you click around here, notice it will highlight your important points. Like down here, we have a bunch of intercepts, we have a min value. So right here are the two intersection points. Okay, these are the points right here where the red and the blue graphs intersect. So we have positive 0.816 and negative 0.816. So which of these is equal to that? Well, it looks like letter C right here, 0.81649, blah, blah, blah. So the correct answer to this is going to be letter C. And also, again, we can move the slider to, whatever, some different value. Let's like move it, way out here. Now, again, notice on the graph, I don't have any points highlighted, but if you click around, so let's see, here it gave us some. Do we see any other? See, the problem is it looks like the issue is that the y value is so large. That's why it's not. That's why I'm having trouble, finding the the clickable point here. Let's try moving it down maybe a little bit to 2. Now here we have all the intercepts. So again, we're looking either at positive 2. Oh, here it is up, all the way up here. 1.915, negative 1.915. There it is. Y value of 33. So again, looking at our answers, it's not 2, it's not negative 4.3, it's positive 1.915. So this just confirms that the answer choice is C. Again, this is the one thing that could be an issue with some of these types of problems is due to the shape, of the graphs, it can be difficult to find the intersection points themselves. All right, so now this is at the bottom of the page. This is the last basically skill or operation that's part of my advanced Desmos skills. And this one is basically solving systems of equations using regression. Now, the main reason why you would want to do this is because it will return the exact value for x and for y as solutions to your system of equations. Meaning, if it's not, if the solution has an x or y value, which is not an integer or, not a nice terminating decimal, um, it'll give you the exact value and allow you to do additional operations with that. So in other words, you need to solve, whatever the system of equations for x, and you get the value for x. And then when you do that, what's going to happen is you need to maybe the question is asking for like what's the value of I don't know, 11x plus 10 or something like that, or 4/3 x minus 5. In other words, it's not just asking for x, it's asking for um, some expression which has that x value in it. So that is an example of where you would want to solve systems of regression equations using regression. Also, if the numbers happen to be really large or really small, um, you can, do it using this method as well instead of having to scroll in or scroll out on a graph repeatedly, trying to find exactly where the intersection point is. So what you're going to do is you're going to type in basically two, really what they are is they're two lists, they're inside brackets. And the first one's going to have the left side of the first equation, comma, the left side of the second equation. Then you put the tilde in the middle because we're doing regression. And then on the right side, you're going to have the right side of the first equation and then the right side of the second equation. Again, for your variables, you're going to want to put them as like, x1 and y1. And this will only return one answer though. So if you need a different answer or an additional answer, you can put restrictions on, let's say, the x1 value to, make it positive or make it negative or make it greater than just some number or less than some number. If you need to find, the other answer, the one that it's not giving you, and you can see here, you just inside curly brackets, you just put whatever the restriction is, x1 greater than whatever 2, x1 less than -7, and then it'll give you, the other answer that you're looking for. So let's look at an example problem here. Here we have a system of equations. Notice these are not linear equations because one of them is a parabola. So what I'm going to do is inside the brackets here, I'm going to do the left side first equation, comma, left side second equation, close the bracket, tilde, and then just the right side top first equation or top equation, comma, right side, just in this case, just a number, second one. Okay. Now, oh, the problem is I forgot to put, there we go, the y1 there. All right, so notice here we have a solution, 2 comma 8. So this question says, what is one possible value of x? So one answer that you could give would be 2. But let's say it was asking for, let's say that what the question actually said was, what is the negative value of x that is a solution to this system of equations? So we don't want positive 2, we want the solution which is negative. So in that case, what we would do is, just put in this qualifier. You could make it less than 0, or if you wanted to, let's say you didn't know exactly what it was, you could just say less than 2. All right, so why is it so, it shouldn't give me 2 because it should be less than. So let me just, there we go, we'll do this. Or just turn it into that. All right, so notice now I get the other solution, which is -1/2, comma, +1/2. So you could also put -1/2 or -0.5 or -0.5. All those would be acceptable as a second correct answer to this problem. So again, this is how you can solve a system of equations using regression, where again, you don't have to graph them. You don't have to try and find the intersection point. Again, this is very useful if the solutions happen to have very large or very small numbers in them, or as I mentioned previously, if one of the coordinate points is not an exact value. And so what I mean by that is it's not an integer or it's not a nice terminating decimal. It's just a decimal that repeats, and goes on forever. So in other words, I guess what I really should say is it's not a rational number, because then you could do operations, like with x1. So if the problem is asking for, what's 4/3 times x minus 5, and then you have the exact answer right here, -17/3 or -5.667 or -5.666. All right, so again, those are the advantages to solving a system of equations using regression instead of just graphing and looking for the intersection point or points. All right, so this wraps up the advanced skills video of my ultimate Desmos guide to digital SAT math. If you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments, please do leave them below. Also, if you haven't done so already yet, do check out the core skills video and the intermediate skills video. I mean, if you've already watched this, I'm assuming you've already seen those and are familiar with the skills and operations that are taught in those. But if not, feel free to go back and watch those and look through them. And otherwise, I will continue to add to this guide in the future. So as I come across, more operations, or maybe there are additional problem types that we haven't seen before, that we can solve using skills or operations in Desmos, I will add on extra videos, showing and demonstrating how to do those as well. But otherwise, good luck on the digital SAT math section whenever you take it.